Okay, ladies and gentlemen, let's talk about geometric means. Geometric means is something where we talk about means, which is an average. Now, normally when we talk about the mean, we're talking about the arithmetic mean. The arithmetic mean is where you add up two numbers and then divide by two if you have two numbers. If you have three numbers, you add up three numbers, you divide by three. You add up five numbers, you divide by five, and it gives you an average. So, for example, arithmetic mean would be where you have like five quizzes. You add them up, divide by five, that's your average quiz grade. Now, geometric mean is a little bit different. If I use two numbers, 6 and 8. So if I do the arithmetic, I get 6 plus 8 is 14. Divide by 2 is 7. That is clearly the average between 6 and 8. However, in a geometric mean, it works a little differently. It's a over x as x over b. So you set it up as a ratio using two proportions. And of course, the only way to set that up and to solve it is to cross multiply. So you have 6 is to x as x is to 8. So the question is, what is this number between the two that makes these two fractions true? So we're going to cross multiply, and I get x squared equals 48. Now, if I do x squared equals 48, I can square root both sides. X equals, well, square root of 48, 224, 212, 2, 6, 2, 3. Pair of twos, left over 3, 4 root 3. Now, normally, we do plus or minus when we do square roots, but since we're talking geometric means, we're only dealing with the positive in this term. You'll notice that 7 and 4 root 3 are not the same. They are not the same. So we need to deal with geometric mean a little bit differently. Okay, if we have this triangle right here, this triangle right here is a big, nice right triangle. I guarantee this is a right angle. If I put this right up in here, it becomes a perfectly right angle. I have right angle here, so I've dropped an altitude. Okay, the idea for this is where the geometric mean comes from. Because what I've done is I've taken a right triangle, and if I drop an altitude, well, I now have this right angle up at the top, so that's an angle that shares, and I have this right angle here. So now I have a right angle in each place, and A is in this little triangle and the big triangle. So what must be true about the big triangle and the little triangle? By angle, they are similar. Same thing here, right angle and angle C, right angle C for the big triangle and the red triangle. Now, to make it a little easier to visualize, let's go this way. And I can take and I can blow this apart. So now what I have is I truly have three triangles. So by taking one right triangle and dropping an altitude, I don't create two triangles, I create three. I have the small, the medium, and the large. Okay, so small, medium, and large. Now, each of these triangles has three sides, a small side, a medium side, and a large side. A small side, a medium side, and a large side, a small side, a medium side, and a large side. If I wanted to, I could do the following. I could take this and flip it over, and let me draw the sides in so you can see it more clearly. There we go. We have this triangle, and we now have this triangle. Again, to make it easier to see, I will color it in. And there you go. So now we have three clearly triangles, even though when they're in the triangle itself, they are in different orientations. You'll notice I had to flip them to make them congruent. So what we can say now is, if I have all these similar triangles, then this side must be similar to this side and similar to this side. And this side, because this is the longest, and the longest has to go with the longest. And so we're going to base all of this geometric mean stuff on this, which allows me to say that if I have two, well, let's call this 6, even though it doesn't look like 6, x and 8, that would make small side 6, this side x, small side x, this side 8. So again, I could say 6 is to x as x is to 8, and that creates my geometric mean situation. So by creating this situation, by simply comparing like sides, I can create a geometric mean. When I cross multiply, x equals 4 root 3. So here we go. This side is going to be 4 root 3. Now, by the way, while we're here, how can I find the third side of any of these pieces? Well, if I know one side of a right triangle and another leg of a right triangle, I can use Pythagorean theorem to find the hypotenuse. So take a look at this, and we'll see where it goes from there.